In the next section in your book, we're going to be simplifying radical expressions. It's 8.3 in our textbook. We have done some radicals like square root of 9 or the cube root of 125, and we have simplified expressions where this square root or cube root or fourth root turns out to be a whole number. What we're going to look at in this section are radicals that are not whole number or integer values, but that still are not considered simplified completely. So the square root of 20 is not a whole number. But again, it's not considered simplified completely. Our rules and our goal when we're simplifying radicals is there can be no factors under the radical with exponents greater than or equal to the index, meaning the root that we're trying to find. So I can't have any factor under the radical to any power greater than 2 or greater. No factors under here to any powers 3 or greater. No factors under this one, powers 4 or greater. And the idea that we're going to use, the rule that we're going to use, it says if I'm trying to take the nth root of a product of 2 or more things, then I can take the nth root of each piece one at a time and multiply those answers together. So the first thing I have to do when I'm looking at numbers like 20 and 40 and 48 is I have to figure out how they break apart into their smallest pieces. I know 20 is the product of 5 and 4. 5 doesn't go any farther, but 4 is 2 times 2. 40, if I break it down, it's the product of 4 and 10. You can start any place that's correct here. You can go 2 and 20, 4 and 10, 8 and 5, whatever pair multiplies to be 40 that you think of first. And then each branch, you break it down until you can't go any farther. 48 is the product of 4 and 12. 4 is 2 and 2. 12 is 2 and 6. 6 is 2 and 3. Got out of room here. And so if we take these numbers at the bottom of our branches, the ones that don't break down anymore, if we put these all back together, that's how we get the number that we started with. So 48 is 2 times 2 times 2 times 2 times 3. Next thing I'm going to do is rewrite 20 as 5 times 2 times 2, but I'm going to use exponents. I'm going to call that 2 squared times 5. I'm going to call 40 2 cubed times 5, and I'm going to call 48 2 to the 4th power times 3. A little variety in that example. Now the rule that we're going to use here is that I'm on an angle there, is that if I have a root of a product of things, I can take the root of each piece one at a time. So that says I can take the square root of 2 squared and multiply it times the square root of 5 and simplify each of those pieces. Well, the 2 square root of 2 squared, when I have a situation where this exponent matches the root, those numbers are the same, all that's going to be left from that is going to be 2. The square root of 2 squared will be 2. Any factor that has an exponent less than the root, that piece is stuck underneath the radical. So square root of 20 is considered simplified completely if we write it as 2 times the square root of 5. If we look at the cube root of 40, we said 40 is 2 cubed times 5 to the first. And again, anytime you have a situation where the exponent of your factor matches the root, they cancel each other out, and you're just left with the factor underneath. So the cube root of 2 cubed will just leave behind a 2. And then if I don't have enough, I only have one factor of 5 here out of the 3 I need to come out. So that 5 to the first is stuck underneath. So 2 times the cube root of 5 is how that one simplifies. Breaking the next one apart the same way. I have the 4th root of 2 to the 4th and the 4th root of 3 to the 1st. Anytime the root and the exponent match, I'm just left with the factor underneath. So the 2 gets to come out and the 3 is stuck underneath. If I have the square root of 180, I start by figuring out how 180 breaks down. I know it's the product of 8 and 10. Sorry, 18 and 10. I wrote it right, said it wrong. 18 is 2 and 9. Minus 3 and 3. 10 is 2 and 5. And so I know 180 is built out of the product of those 5 numbers. If I put them together, I have 2 2's. So who knows what I just did there? 2 squared. I have a 3 squared. And I have a 5 out of that. If I take the square root of 2 squared, and the square root of 3 squared, and the square root of 5 to the first, any place the root and the exponent match, that factor gets to come out. So the 2 gets to come out. The 3 also gets to come out. And the 5 to the first power is stuck underneath. Now what we're going to do from here is we're going to put the numbers out in front together. I have the product of 2 and 3. I'm going to call that 6. I end up with 6 times the square root of 5. The examples in this section get a little bit longer. I can add x squareds and y squareds. I can make factors where they're bigger. There's more of these than my root, and we can talk about how to break those apart. But I think at this point I'm going to save that until I get back. And the next class period we should be able to wrap this all together and then do the next section or two on the products and quotients as well. So I'm not going to give you an exercise assignment from this. I'm not going to assign any problems from here until I get back to campus, and we'll look at it together.